Okay, another example of computing an implicit derivative. This time maybe just a little bit tougher, but the process is exactly the same. We've got an equation of x and y, maybe a function, maybe not, probably not a function, probably couldn't solve this for y. But regardless, if it's any kind of an equation, it's got some graph in the xy plane. If we find points on that graph, we might want to compute the tangent line at that point, or at those points, or the slope of the tangent line. To do that, we need the implicit derivative. Okay, so again, we've got the equation. We don't need to do anything to it. We can just take the derivative of both sides. So I take the derivative of the left side, set that equal to the derivative of the right side. Okay, and from here we just start using the rules of calculus that we have to compute derivatives. Now, again, a couple of things here. I'm going to go ahead and erase something here and insert a little step. There's always a little bit of simplifying we need to do. 3 over y, again, it's very helpful to write this so it's not a fraction. Okay, I'm going to write that as 3 times y to the power negative 1. So just a little rewrite there. Okay. So now it's basically on to computing some derivatives. Okay, derivative of the first term here. Well, we've got the derivative of 4x squared y. Well, I'm going to take the derivative of that term, okay, but since 4 is a constant, I'll factor it out. Okay. Now over here, I've got the derivative of 3 times y to the power negative 1. But again, I'll factor that constant of 3 outside. Okay. Now on the other side, derivative of 0, well, hey, guess what? That's 0. So we can go ahead and compute that one. Okay. So now let's go back and compute these derivatives, which do require implicit differentiation. Okay. So what about this? Okay. Well, if you look at this, you actually can't get by too easily. You need the product rule here. We've got x squared, okay, a function of x, times y, which we treat as a function of x. Okay. So it's just the product rule. This is our first function, x squared. This is our second function, y. Okay. So what am I going to multiply 4 by? Well, I'm going to multiply it by this derivative, which comes from the product rule. Remember the product rule, we have a first function that we call f and a second function that we call g. And what the product rule says, take the second function times the derivative of the first. So we've got y times the derivative of x squared, which is 2x, plus the first function times the derivative of the second. Well, the derivative of y with respect to x, again, it's dy dx. That's our implicit derivative there. Okay. Everything works normal until you take a derivative of an expression involving y. And then you just call the derivative dy dx. Okay. If it's y to a power, we have to use the generalized power rule there. Okay. And again, over here, I just have y to a power, so I can use the generalized power rule. Derivative of y to the power negative 1 is going to be negative 1 times y to the power negative 2, okay, times the derivative of y, so times dy dx. Okay. So again, when I took the derivative of the second function in this product, and when I took the derivative of y to the power negative 1, that's where I actually differentiated implicitly. Okay. Treated y like it's a function. Okay. Okay, well, a little bit more writing and simplifying and so forth. So I'm going to erase some of these earlier lines and get back to where we are. Okay, well, what do I have here? Let me collect some terms. I've got, looks like 8xy, okay, plus 4x squared times dy over dx, okay. And then here I'm going to have plus 3y to the power negative 2, okay, times dy dx equals 0. Okay. Now, basically your goal in this problem, they asked you to just find the implicit derivative. So we need to solve this equation for dy over dx. Okay. So it's just like solving really any other equation. The thing you want to solve for, dy over dx, appears in 2 terms. So we move everything else to the other side. So let's subtract 8xy from both sides. Okay. Well, and over here I get, let's see, over here I have the negative 8xy. Okay. But over here I just have these 2 terms. Okay. And they both have one factor of dy over dx. So I can actually factor this out of both of those terms, 4x squared plus 3y to the power negative 2. Okay. And to get this by itself, I just need to divide both sides by that second factor, 4x squared plus 3y to the negative 2, 4x squared plus 3y to the negative 2. Okay. So dy over dx, the derivative of y with respect to x, is negative 8xy over 4x squared plus 3y to the power negative 2. Okay, and that's basically the final answer. Again, you know, the book is kind of picky about leaving negative exponents. It probably wouldn't like this y to the power negative 2 here. Of course, it's actually a pretty easy thing to fix. You just multiply the numerator by y squared and the denominator by y squared. Okay, what's that going to do? Well, if I multiply it inside here, I'll get negative 8xy cubed, okay, 3 y's now. And then if I distribute the y squared into the denominator, I'll have 4x squared y squared, okay, plus, now when I multiply these two powers of y together, I add the exponents, and I get y to the power 0. So 3 times y to the power 0, which is just 3. Okay, y to the power 0 is 1. Okay, so that's the final answer, probably what you'd see in the back of the book on this one.